2021 Trigo proving question. Alright, let's take a look at this one here. Now we're asked to prove this identity here, and we'll start from the left hand side since that's the side that is more complicated, where there's more potential to work on. Okay, whenever you do proving questions, always look at the other side to give you cues on how to proceed. And looking at the right hand side, since there's only one Trigo function, it will make sense to actually combine these two fractions into one. And to combine these two fractions, we need to get a common denominator. So since there are no common factors there, the common denominator that I will get would be just the product of 1 minus cosine theta times sine theta. And to get this common denominator, I must multiply by sine theta to the top and bottom, right? So that gives us a sine squared theta. To actually get this common denominator, I need to multiply 1 minus cosine theta to the top and bottom here. So I will have minus 1. Okay, don't forget you need your brackets there. 1 minus cosine theta. So let's simplify the numerator as much as we can. Okay, now if you look at your numerator, if you were to leave it like that, there's nothing much that you can do. If you observe the denominator, I wouldn't expand because likewise, there's nothing much that I can do if I were to expand it out. So what I realized is there's a square for my sine theta. When you see squares of Trigo function, try to use your Pythagorean identities. So I can actually apply one of the formulas there. In fact, the first one, which states that sine square A plus cosine square A equals to 1. So using this identity here, I can make sine square my subject, get rid of the cosine square, and I can use this to substitute into our numerator. So we'll have 1 minus cosine square A minus 1 plus cosine theta. Sorry, I should have written this as a theta instead. By doing this, right, you realize that everything in your numerator now becomes cosine. Notice we have a 1 minus 1 which cancels off. Okay, and you end up getting cosine theta minus cosine square theta. Notice the top, cosine theta is a common factor, right? That allows us to factorize out that cosine theta, okay, which leaves us with 1 minus cosine theta. Okay, notice that you have a common factor, 1 minus cosine theta, that exists in the numerator and denominator. So cancelling off that common factor, it leaves us with cosine theta over sine theta. This is equivalent to our cotangent theta. And that's how we do this proving question.